Before explaining how piezocrystals work, it is very important to understand what these crystals actually are. We all know that a crystal is a substance in which the constituent particles are arranged in a repeating three-dimensional pattern. The piezoelectric effect is the ability of a material to generate an electric charge in response to mechanical stress or pressure, like a squeeze or a push. If we combine these two definitions together, it is very easy to perceive what piezocrystals are. On applying mechanical stress on these crystals, you can make electricity flow through them. The reverse is true as well. That is, if you pass electricity through the same crystals, they squeeze themselves or deform in shape.
How are they different from regular crystals? In most crystals, the unit cell, the basic repeating unit, is symmetrical. For example, in sodium chloride, the positive charges balance out the negative charges. Also, the sodium and chloride ions form a repeating and symmetrical pattern as such. In piezoelectric crystals, this is not the case. Though piezoelectric crystals are electrically neutral, or the positive and negative charges cancel out each other, the atoms inside them are not symmetrically arranged. When pressure is applied to normal crystals, this pattern of ions shifts so that the two ions with the same charges are brought into alignment. When this happens, the ions in the compound undergo electrostatic repulsion, splitting the compound. If you apply pressure to a piezoelectric crystal, you deform the structure, pushing some of the atoms closer together or further apart. Ions with the same charges do not necessarily come into alignment because the ions in these crystals are not symmetrically arranged. Instead, the balance of the positive and negative charges is disturbed, and that causes net electrical charges to appear. This effect carries through the whole structure, so net positive and negative charges appear on opposite outer faces of the crystal. This creates a voltage across the crystal and causes a flow of current when electricity is passed through it while it's being squeezed.
Piezocrystals are very easy to make, just took us about 2 months. The ingredients required are soda ash or sodium carbonate, cream of tartar, distilled water, filter paper, and Pyrex containers. First, we add cream of tartar to distilled water in a Pyrex container. This container is then placed in a saucepan filled with boiling water and is heated. After that, soda ash is added to the mixture, 1 teaspoon at a time. Adding sodium carbonate to the mixture makes it fizz. However, when sodium carbonate is added to it over a long period of time, the fizzing dies down to give way to a clear solution. The reason for fizzing is the acid-base reaction that is occurring during the process. Cream of tartar has tartaric acid, which reacts with the base, that is sodium carbonate. The reaction produces a salt, carbon dioxide, and water. This solution is further filtered using a filter paper. Following this, it is left to cool down. The salt, when left to cool down, forms a crystal because it is a supersaturated solution. A supersaturated solution is a state of a solution that contains more of the solute than could be normally dissolved under normal circumstances. The end result is a perfect piezocrystal.
These crystals can be used as a renewable source of energy to generate electricity. For instance, they can be used in traffic lights, as transducers in shoes, and even dance floors. The main idea is that as humans drive cars, walk, or dance, pressure is applied to these crystals and they are able to generate electrical current. Just like old radios and TV sets, these two work only when hit on, and provide an excellent example for technological evolution.
Created using Powtoon.